Hello friends, good morning. In the article on protection of transmission line against direct lighting strokes, I was discussing about the factors related with the ground conductors. I had already discussed pre-discharge current, isochronic level, back flashover, shielding angle, and tower footing resistance. The last factor to be discussed is coupling factor, denoted by K. This is the diagram electrical equivalent circuit for tower as well as power conductor. I will discuss this step by step. Then I will explain what is coupling factor. Let us say this is the tower. This is ground. This is earth. This is tower. Now, as tower is metallic structure, we represent its electrical equivalent by resistance and inductance. Resistance term I had discussed in my last class, that is tower footing resistance. L is very small, that is in the range of 10 microhenries, whereas tower footing resistance is in the range of 10 to 30 ohms. So this is the tower. Now this is the ground conductor connected to the tower to attract the lightning stroke. This is power conductor. Now this power conductor is connected to the tower through string of insulators and cross arm. So this point and this point, they are at the same potential, that is the zero potential. C1 is the capacitance between power conductor and the ground conductor, or let us say between the tower and the power conductor. C2 is the capacitance between this power conductor and the earth. This C2 you have studied in power system, that is capacitance of the transmission line, and this C1 is nothing but the capacitance of the string of insulators. So power conductor, these are capacitances, this is tower, resistance and inductance. Now in normal condition, this tower top will remain at zero potential because it is directly connected to the earth. This power conductor will be having the system voltage, per phase system voltage. Now when lightning strikes this ground conductor, that lightning stroke is discharged through this tower. So when lightning strikes, the tower top is subjected to high voltage. That we are denoting by Vm. This is Vm. So when lightning strikes, the tower top is subjected to high voltage. That we denote by Vm. Now let us find out what is coupling factor. Let us say A is distance of this power conductor from the ground conductor. B is distance of this power conductor from the earth. H is height of the ground conductor from the earth, and R is the radius of the ground conductor. Then coupling factor K is given by log of B upon A divided by log of twice H upon R. So here B, A, H and R, that is radius of ground conductor, height of ground conductor from the ground, A, that is distance between ground conductor and the power conductor, B is distance of power conductor from the ground. They all factors are decided by the mechanical considerations. So we can say that K is decided by, that is coupling factor is decided by mechanical considerations. That is one thing. Now let us say lightning strikes this ground conductor. So this tower top is subjected to voltage Vm. Now one equation for this Vm will be current is flowing like this. IL is the lightning current. So in this circuit, Vm will be RT, that is RT is tower footing resistance into IL. IL is lightning current, lightning discharge current, or we can say that it is stroke current, plus L di by dt. Simple equation, simple first order differential equation. So that is one equation for Vm. Now this C1 and C2, they constitute capacitance potential divider. So second equation for Vm will be V1 plus V2. Vm is equal to V1 plus V2. Now, V2 is equal to K into Vm, where Vm is the tower top potential when lightning strikes, K is coupling factor. So when we substitute V2 in terms of KVM, we get this equation V1 is equal to, in bracket, 1 minus K Vm. Now what is V1? V1 is the voltage between the ground conductor and the power conductor. Now this V1 is responsible for the back flashover. Now if V1 is large, probability of back flashover will be more. So in order to avoid the probability of back flashover, we have to reduce V1. Now look at this equation. V1 is 1 minus K into Vm. So V1 can be reduced either by increasing K or by reducing Vm. Now K is decided by the mechanical considerations. So from electrical point of view, we cannot do anything with that K. Only thing we can do is Vm with Vm. So Vm is this equation. IL is lightning stroke current. We cannot control it. That is natural phenomena or beyond our control or external phenomena. So RT and L. L is very, very small, that is in the range of 10 microhenries, whereas RT is in the range of 10 to 30 ohms. So in order to reduce Vm, we have to reduce the tower footing resistance. This is how this tower footing resistance affects the back flashover. So we have to reduce the tower footing resistance. If this is reduced, Vm will be less, Vm is less, V1 will be less, V1 is less, probability of back flashover will be less. So in next class, I will explain how this tower footing resistance is reduced. If you feel this lecture useful to you, then please like it. Ask your friends, your colleagues, your juniors. You also subscribe to my channel for upcoming lectures on high voltage engineering and power system protection. If you want to make efficient and effective use of time, then read my book on time management. I have launched one useful course for students on UDEMY. The link for this course is given in the description box. This course is useful for students in general and specifically for the students who are preparing for entrance and competitive exams. Thank you.